Hey guys, so today we're going to have a look at some more financial math questions. In particular, we're going to be looking at it from a different use of techniques that we can use. So this one's going to focus more on APs and GPs and how they're helpful in answering financial math questions and kind of differentiating between the two of those. I've noticed that financial maths is definitely a trickier subject, trickier topic for a lot of different students. It does pop up in the standard course as well, but not the AP and GP side of it. So this side will just focus mainly on the different financial maths questions that can be asked in the advanced course. So to go through this example, we're going to be having a look at this question here. So we're told that Kim and Alex start jobs at the beginning of the same year. Kim's annual salary in the first year is $30,000 and then increases by 5% at the beginning of each subsequent year. We're also told that Alex's annual salary in the first year is $33,000, and then that increases by $1,500 at the beginning of each subsequent year. So the first part of this question for part I, we need to show that in the 10th year, Kim's annual salary is higher than Alex's annual salary. So to solve for this question, what we need to do is find each respective salary. So find Kim's salary and then find Alex's salary. And then hopefully our end result will be that Kim has a higher salary, and therefore we can prove it in that way. So we're trying to find the value of each of their salaries after 10 years. So let's have a bit of a deeper look at what Kim's salary is going to look like. We're told that highlighted in the yellow there that it starts at 30,000. It then increases by 5% each year. So 5% of 30,000, we can add 5% to that. So we go 31,500. Then taking another 5% and adding onto that, we then get the next subsequent year being 33,075. So if we want to see what's happening here, each time that we're increasing this by 5%, we're timesing the previous number by 1.05. If we had just timed it by 0.05, we would have just been taking 5% of that. But what we've been doing is taking 5% of that and then adding it on. So we're timesing it by 1.05. So what we actually have here then is a GP, or a geometric series, with an A value or a starting value of 30,000 and an R value or a common ratio of 1.05. So if we want to find the value of her salary after 10 years, we need to be taking our GP formula when T is equal to 10, where N is equal to 10. So we find the value of the term after the 10th year, which is AR to the N minus 1, which is going to be AR to the 10 minus 1 for T of 10. Okay, we said our A value was 30,000 and our R value is 1.05. This should be 10 minus 1. So therefore, that's going to be to the 9th power. So 30,000 times 1.05 to the 9 is going to give me $46,539.85 to the nearest cent. So that's Kim's salary. What we can then start to have a look at is what Alex's salary is going to look like after 10 years. So we create some more space here. We're now going to have a deeper look into Alex's. So highlighted in the pink there, we say Alex's annual salary is the first year at 33,000. So we now are starting at a salary of 33,000. And then all we're doing there is just increasing by 1,500 each time. So we can expect that to go to 34,500. And then the next value would be 36,000 and so on. These would be keep increasing. So what's happened each time here in Alex's salary is that we're just adding by that $1,500 amount. So therefore, we have an AP or an arithmetic series with an A value of 33,000 and a common difference now, a D value of 1,500. So we know that the value of the term after n years is going to be A plus n minus 1 times D. So the value after 10 years, so the value of Alex's salary after 10 years is going to be 33,000, our A value, plus 9 minus 10 minus 1, which is 9, times D, which is 1,500. Plugging that into your calculator, and what you get as your final salary being 46,500 after 5 years. So therefore, these are our two salaries for each respective person, so Kim and Alex. So therefore, $46,539.85 is greater than just $46,500. So therefore, Kim's salary is greater than Alex's after 10 years. And that's exactly what we need to prove for part I. So that's part I done, splitting it up into the APs and the GPs there. If we then move on to part II, it says that we need to find that in the first 10 years, how much in total does Kim earn? So how much in total? So instead of looking at what the value of of her annual salary is going to be in the 10th year, the key word here is total. So we're actually taking the sum formula. So Kim's was a GP. So we're going to be taking the sum of a GP after 10 years, so S of 10. So we know that S of n is equal to A outside of R to the n minus 1 all over R minus 1. So therefore, S to the 10, we said that our A value for Kim was going to be 30,000 times 1.05 to the 10 minus 1 all over 1.05 minus 1. Then all we have to do there is just plug that into our calculators, and we get $377,336.78 once again to the nearest cent. So therefore, that's the total amount that she's made after 10 years just by using that sum formula there. We can then have a look at part III now. So having a look at part III, we're told that every year Alex saves a third of her annual salary, and we're going to find how many years does it take for her to save $87,500. So here we're going to be solving for our n value because n was our number of years in each of these different formulas that we've been forming. So if she saves a third of her annual salary, so we know that her salary after 1 year was going to be her starting amount, so $33,000. Her T2 salary was $34,500. And then Alex's T3 salary, her value after third year was $36,000 and so on. So just so that we can start to get a pattern, I'm just going to once again write down the first three values that we found. What we can then do is, because she's only taking a third of that, we want to make sure that we represent this in our equations. So we're going to times all of these by 1/3, just so that we're only taking a third of it. 33,000 is going to be 11,000, 11,500, and then 12,000. So, for example, in the first year, she's saving 11,000. In the second year, she's saving 11,500, and so on. So what we can see kind of forming here is a different AP. So this side here forms an AP. With now we have an A value of 11,000 and a D value of 500 because it's increasing by 500 each time. Okay, so what's happening is she's putting this money into the account, and each year she's adding more money to the account. So we have a total value adding up here. So she adds and she adds. So therefore, to find the total amount that she's saved in all of the years up to $87,500 into her account, we want to be taking the sum formula once again. So we want to find the value of n such that the sum after n years is equal to $87,500. So taking the sum of our AP formula, which is S of n is equal to n over 2, 2a plus n minus 1 times your common difference. So therefore, plugging those values in, we get 87,500 is equal to n on 2, because we don't know what our value of n is, times 2 times A. So our A amount was $11,000 So 2 times 11,000 is 22,000 plus n minus 1 in brackets times our d value of 500. We can then expand this out, so we get 87,500, keeping the n over 2 at the front for now. We get 22,000 plus 500 n minus 500. What we can do now is we can now expand out the first term of n over 2 at the start. So we get 87,500 is equal to 11,000 n plus 250 n squared minus 250 n. So timesing everything by n and then dividing by 2. And now I get all my like terms on the same side. So I've got this 250 n squared there. So I know that because I've got my power to the n, I'm going to have some sort of quadratic sign to form. Then I've got my middle terms, and then I've got my 87,000 constant term on the left-hand side there as well. So I get 250 n squared plus 10,750 n minus 87,500 just by bringing it across is equal to 0. That's quite difficult for me to factorize at the start here because I've got such big numbers. So let's divide everything by the common factor of 250. So now I get n squared plus 43 n minus 350 is equal to 0. And what we're looking for now is to factorize this quadratic. So we have factors of negative 350. They're going to add to give 43. So when you try a bunch of in your calculator, you can use a quadratic formula here if you want as well. But after trying a bunch in my calculator, I found out that 50 and negative 7 times together to equal negative 350 and add to give 43. So I can go n minus 7 times n plus 50 is equal to 0. Therefore, I get n is equal to 7, and I get n is equal to negative 50. Now, n has to be greater than 0 because it's a number of years. So you can't have negative 50 years go by. So by establishing that in my answers there, I get n is equal to 7. So therefore, my value of my investment account is going to hit my 87,500 after 7 years. So that question was all about kind of identifying which AP or GP formula to use and when we can kind of see when to use the sum formula. So that last question was a little bit more difficult to kind of see what's happening. But if we just write down everything that we've got going on, so writing down all of our different terms and values, you might be able to see some sort of pattern and series start to work there. That's going to help you a lot with those questions. So hopefully those help to answer those kind of questions there.